Okay, this is the note sheet for the final exam. Simplify using the laws of exponents. And remember, when we're multiplying powers of the same base, so when you're multiplying powers, you add exponents. So you write 5 and then you add the exponents, which is 5 to the 7th. And then you type this into your calculator, 5 caret 7, enter, and that will give you your value there, which is 78,000. So that's what 5 to the 7th equals. All right. Now, and then I'm going to give you one of each to practice. Okay. So now when you're dividing powers, remember, when you're doing this, the base numbers have to be the same, or this doesn't work. This only works when the base numbers are the same. So multiplication, the opposite of multiplication is dividing. The opposite of adding exponents is subtracting exponents. So we can write 8 in the numerator and then take the numerator exponent, subtract the denominator exponent, which is 6 subtract 5 is 1, and 8 to the first is just 8. When you raise a power to a power, well, if something's squared, it means the exact same thing times itself. Well, now we've got powers being multiplied, so you would add the exponents. 4 plus 4 is 8. But an easier way to do that is when you're raising powers to another power, you multiply exponents. So instead of writing that, you could just say, oh, we're raising this power to a higher power, we can multiply. So 6 to the 8, so type in your calculator, 6 caret 8, enter, which is 1,679,616. So that's what they mean by powers. Look at, you take a number like 6. That exponent of 8 is not very big, but it's very powerful because 6 multiplied against itself 8 times let's see, 1, 2, 3, 4. That doesn't look like very much, but it ends up more than 1.5 million. So, all right, now we're going to switch to writing numbers in scientific notation. And when you do that, you're multiplying it by powers of 10. When the lead number starts with 0, when you change it, and so then you rewrite in scientific, the 10 will have a negative exponent. But when the lead number starts with a number other than 0, when you multiply it, when you turn it into scientific notation, it will have a positive exponent. So this number right here, when you change it, will have a positive exponent. This number over here, the lead number is 0. This will be a negative exponent when you change it. All right, so this is the process to changing it. Whenever it's just a standard number, so that's 91 million, you put the invisible decimal point, because that is 91 million.0. We're going to move the decimal point 1, 2, 3. That makes sense. There's a comma. 1, 2, 3. So that's 6. 7 times. So then we rewrite it as just 9.1. We can ignore all those zeros times 10, and we move that 7 places. Now over here, I'm going to do this one with you. Over here, there is the decimal. We know that's going to be a negative amount, but the decimal has to go right after the first non-zero digit. So it has to be 4.2. Well, we moved it 1, 2, 3, but the 3 just gets a negative number because the lead number, that means this number right here is less than 1. All numbers less than 1, or on a number line, all numbers that are bigger than -1, but less than 0, these get a negative exponent too. All right. So essentially what that means is if you had negative 0.0042, that would be negative 4.2 times 10 to the negative third. That's probably a clearer way of writing that. All right. Now we're just going to change this back. So if you have 10 to a negative number, that tells you you're going to move the decimal in the negative direction. If you have 10 to a positive exponent, you're going to move the decimal to the positive direction. So this tells us we're going to move the decimal 5 places that way. So I'm just going to put, let's see, I'll put 2.9 over here. So I have to leave room for me to do zeros. Remember, if you go in the negative direction, eventually when you put the decimal point, you also have to remember that you have to add an extra 0, because if it's a decimal number, you always must write that lead 0. All right, we're going to go 5 places. 1, 2, 3, 4, 5. Put the decimal and then put the lead 0. And in each of those empty waves, so now what we have, I'm going to rewrite it. We have 1, 2, 3, 4 zeros, and then 29. Just like that. Okay, on these, they're telling you that these shapes are similar. Similar means proportional, which means you set things up as a proportion. And a good rule of thumb is identify the side that corresponds with the x, and you always want the x in the numerator. And then to make sure you know what you're doing, this is the small shape. This is the big shape. So over here, the small side will go in the numerator. The big side will go in the denominator. So this is the small shape. And I don't really need that highlighted. And then 144 is the big side. Now, to get the x by itself, well, it has a divide 88.8. So to cancel dividing, we're going to multiply. When we do that, extend this line so you remember how to multiply correctly. So in your calculator, you're going to type 12 times 88.8 divide 144. And when you do that, the result is 7.4. But because this is a side length, even though CUDA software didn't, they should have, you should always put a unit measure. And if they don't give you one, you just put the abbreviation for units. I'm telling you, this labeling is going to save you, because the errors that students are making is that when you go to set up the second proportion, you flip the sides because you don't know which one goes where. So label, this is on the small shape. The X is in the numerator. That means the small values go in the numerator. This is the small shape too. This is 12 is part of the small shape. So we had to put 12 in the numerator. All right. So this is more proportional reasoning. So a model igloo has a scale. So whenever you see a scale, that's the proportion. It's saying 1 to 4. Now over to the side, I'm going to put inches for the 1 and feet for the 4. So over here, I know I'm going to put inches in the numerator and feet in the denominator. And then identify what they tell us. If a real igloo, they tell us the feet. So I know that is going to go in the denominator. I should have put that down a little bit. There we go. And that means we don't know then how wide, if the real igloo is 12 foot wide, then how wide, well, we don't know how wide the model will be. So we give it a W. And again, so notice what I did here. This is the model. This is the real. So over here, this is the model. This is the real. If you're not knowing how to organize the information, your answers are going to be wrong. Okay, we want to get this W by itself. So it has a divide 12. So we just multiply both sides by 12. Now be careful when you do that. 12 times 1 is 12. So in a calculator, you could do 12 times 1. Or if you just know, oh, well, that's 12. 12 divided 4 is 3. And then notice it was the model that we are looking for. So we would say 3 inches is equal to the W. Okay, I'm going to do a shadow. You guys probably don't even know what a telephone booth is. So a telephone booth was this. I used them all the time. Well, I mean, not all the time because, I was a kid. So it had this door you open up, and on the wall was a payphone, and you would put in, it used to be a dime, then it went to a quarter, and you dial the number, right? So here's a stick figure of somebody, and then they put the phone to their head to listen, whatever. All right. So a telephone booth so this height is 8 feet. It casts a shadow. That is 20 feet long. All right. Find the height of a lawn ornament. I'm just going to do like a Christmas ornament. I don't know what I'm drawing there here. This is a Christmas ornament. There we go. And its shadow is 10 feet. So what we don't know is this height. But look at what we have. We have a proportion. We can compare the heights. So we could say the height of the lawn ornament, let's see, here's the ratio. Since we don't know the height of the lawn ornament, so this is the lawn ornament, this is the phone booth. Heights. Now we're going to compare it to the lengths of the shadow. So this is the lawn ornament shadow, and this is the phone booth shadow. And some of you can do that in your head. You can say, well, 10 is half of 20, so this height has to be half of 8, which is 4. The other way to do it is then just multiply both sides by 8. And then 10 times 8 is 80 over 20, which is 4, and that will be in feet. So the height of the lawn ornament is 4 feet. All right. Gabriella bought one seedless watermelon for $2. So this is the watermelon, the number of watermelons, and this is the cost. So this will be the cost, and this will be the number of watermelons. How many watermelons? Oh, we don't know, so we're going to put W for watermelon. If he has $4, this is the money. So you just organize the information so you set up a correct proportion. Well, again, we have a divide 4, so we're going to multiply 4. 4 divided 4 is 1. 1 times W is W. But if we multiply, remember the teeter-totter, if we do something to this side to keep that teeter-totter balance, we have to do the same thing to the other side, the equality property of multiplication. 4 times 1 is 4. 4 divided 2 is 2. Whoops. Oh, what I should have told you is there's a dollar sign, there's a dollar sign, and then the dollar signs cancel, and then when you get 2, that's the number of watermelons. All right. The proportional method in finding percents. Remember what I showed you. Put the of here and put a right arrow, because then when you see the word of, put a right arrow and you know, oh, 34 is what goes there. 100% will always go there. Then there's a percent symbol here, and then put an arrow to the left. So then you identify, oh, well, that's not a percent sign, but it's the word percent. Whatever's to the left, well, that's the word what. That means an X is going to go there. Anything that's left will go in the blank spot. And now we have our proportion. Percent divide percent, we can cancel those. Now we have a divide 100. We're going to multiply both sides. Now, in your calculator, 100 times 26 divide 34. And what the calculator will read is 76.4705, and it's going to keep going on. That's exactly what X is equal to. That's the exact. But let's go ahead and round to the 10th, and we're looking for a percent. Well, this 7 will cause that 4 to round up to 5, so we end up with 76.5%. Let's see if that's true. What percent of 34? So if you've got 0, and this is 34. Well, 50%, half of 34 is 17. So between 17 and 34, you're going to have 75%. Well, that makes sense. 26. Well, 26 is a little bit more than 75. So halfway between those, if we go 8.5 up and 8.5 down, that's what we end at there. Well, 26 is just after that, which is the 76.5 amount. So that gives you kind of a reasonableness. This is the setup. Please, please, please remember to do this. And it's after the word of. And then it's to the left of the percent sign is what goes there. Find the original selling price. So in this one, we just have a tax. Well, a tax is something you add on. Well, if we have to pay all of that, that's 100%. Well, 100% plus 6% is 106% that we're going to have to pay. Move the decimal 2 places to the left. We just have to multiply this by 1.6, and that gives you the total price. So let's do that now in the calculator. Let's type in, there we go, $19.95 times 1.06. And that gives us 21.147. Remember, we can only go to the hundreds place with money. So this 7 will cause that round up to 15 cents. So this is $21.15. All right, that's it. This should help you prepare for the final exam.